Let's look at this problem. This is an interesting analytical geometry problem. It says the interior of a quadrilateral is bounded by the graphs of this form and this form, where A is a positive real number. What is the area of this region in terms of A, valid for all A greater than 0? Good. So actually I think the author of this problem has made it easier, because the description of the problem gave a lot of hint about these graphs. Since it says the picture that is bounded is a quadrilateral, then we know that it must have 4 straight lines so as to form a quadrilateral. Therefore, these two expressions has to define 4 straight lines, or 4 lines in the coordinates plane. And then let's look at these two equations. Each equation is in the format of a square of an expression equals to a square of another expression. Therefore, we know that we can just simply take square roots on both sides. And let's take the second equation, for example. If we take a square root on both sides, the ending equation will be ax minus y equals plus and minus a. That is obviously a linear equation, which defines 2 parallel lines, right? And then we can start our calculation, because this quadrilateral will be of a special form. It's not a general strange shape quadrilateral. Good. Then let's start it. As we said, we want to take square roots on both sides of both equations. Then the first equation becomes x plus ay equals plus and minus 2a. The second equation becomes ax minus y equals plus and minus a. Obviously, these are 2 pairs of parallel lines, which is a total of 4 lines. And from the first pair, we know that the slope is actually minus 1 over a. And the second pair gives a slope of a. Then we know a few facts from these expressions. First, this quadrilateral is actually a parallelogram, and the shape should be like this, right? Each pair should be just like this. And then from the slopes, the 2 slopes, we know that let's call the first one k1 and the second slope is k2. And then we know that the product of the 2 slopes equals -1. This means the 2 pairs of lines are perpendicular to each other. If we put them in the graph, they should be like this. This is the second pair of parallel lines. And these angles are all 90 degrees. Beautiful. So now we know that this quadrilateral is really just a rectangle. In order to calculate the area of a rectangle, we only need to know the side length of this and this, right? And which are simply the distance between each pair of parallel lines. And in general, we know that we have this formula. If we have this general form, ax plus by equals c1, and ax plus by equals c2, we have this pair of parallel lines which are in the general form. Then the formula tells that the distance between these 2 lines is the difference of these constant terms, which are related to the intercept of these 2 lines. So c1 minus c2, and then take the absolute value. Because we don't care about the directions, the distance got to be a positive number. And then over square root of the sum of square of these two coefficients, which is a squared plus b squared. This is our general formula. If some students forget about this formula, they can take another approach. They can take some special point. For example, their intersects, or maybe the slopes in here or anywhere, some special points, and apply the formula of the distance from a point to a line to calculate the distance. And that will certainly takes a lot more time. Actually, I've tried that. I think it'll probably take you 3 to 5 minutes at least. Therefore, when you prepare for such exams, you better go over all the necessary formulas, especially the very useful ones. So now the problem is really to apply this formula on top of these two pairs of parallel lines and get the two distance, and then we multiply them. That will be our answer. Good, let's do that. So the distance between the lines in the first pair is, the numerator is 2a minus negative 2a, because a is a positive number. So that gives 4a over square root of a squared. A squared here is 1. The coefficient of x is 1. So 1 squared plus the coefficient of y, that is a squared. And this equals 4a over 1 plus a squared, right? And the distance between the second pair of lines is, the numerator is a minus negative a, that is 2a. And the denominator is square of x coefficients, that's a squared, plus the square of y's coefficients, that's negative 1, so that is 1 squared, which equals 2a over a squared plus 1. Therefore, our distance is just d1 times d2. That is the formula for a rectangle's area, which equals 8a squared over a squared plus 1. So this is our answer. Then let's check the 5 choices. So D is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.